Hey guys, welcome to video number 2. In this video, we're going to walk you through example 2, which will give us an idea of how to conduct a significance test for a 2-sample data based on what we know about 1-sample tests. So example 2 on page 3 in your notes is asking about what proportion of college graduates get jobs. A random sample of 500 recent Michigan grads revealed that 460 of them got jobs. A separate random sample of 400 Michigan State grads revealed that 352 got jobs. So we want to know if this data provide convincing evidence that a higher proportion of recent grads from Michigan get jobs than Michigan State grads. And we're going to conduct the test at a 5% significance level. In the box on page 3 in your notes, we're going to fill in the formula for the test statistic. And the test statistic for a 1-sample z-test is in the little box over to the left. And remember, with that formula, we did p hat, which was our statistic that we find from our sample, minus p naught, which is the value we speculate in the null hypothesis. And then we divide that by the standard error of our statistic, which we calculate using the null hypothesis value because we're assuming that to be true. Here's what the formula looks like for 2 samples. So go ahead and take a minute to copy that down, pause the video if you need to. We're still working with z because we're using proportions. The numerator this time is just going to be the difference, p hat 1 minus p hat 2, so the 2 proportions we calculate from our 2 separate samples. And the denominator this time, notice, looks a little bit different. And we are calculating the denominator with what's called the combined proportion. And notice in the bottom left-hand corner of that box is a formula for calculating the combined proportion. And what that says is to count up the number of successes in both samples combined, divide that by the total count of the individuals in both samples combined. Because if we are assuming in our null hypothesis that the 2 proportions are the same, then we can really lump them together into one group, and it doesn't matter whether the sample sizes are the same or different. We should be working with the same proportion either way. All right, so let's go ahead and conduct the test. It starts at the top of page 4 in your notes. Since we're doing a significance test, we use phantom, so we're going to do all 7 steps. The parameters we want to investigate are P1 and P2, and we need to specify which one is which. So I'm going to let P1 be the proportion of U of M grads who get jobs. P2 is going to be the proportion of MSU grads who get jobs. Now, for our hypotheses, there are a couple of different ways that you can write them. Remember, we are going to assume that the proportion of grads who get jobs are the same, regardless of what college you go to. So our null hypothesis will be that P1 equals P2. And we're speculating that U of M grads get jobs more often than MSU grads. So our alternative is that P1 is greater than P2. And this again kind of illustrates why it's important to define which one is P1 and which one is P2, because if you flip-flop those and have MSU be P1, then that would change the direction of your inequality. So it's really important to define those. Now, another way that you can write those is you can say that your null hypothesis is that P1 minus P2 equals 0. So essentially saying there is no difference in the proportion of graduates who get jobs from either college. Your alternative would then be that P1 minus P2 is greater than or just greater than 0. So 2 different ways, and whichever way you choose to write those hypotheses are the same. This way, I think, makes kind of clear that the null hypothesis value is 0, which is a little more similar to what we did back in chapter 9 when we were working with 1-sample data, but I'm really fine with either method. Now, for the assumptions, it is stated in the problem that random samples were taken, and they are 2 separate random samples. We are going to check the conditions, and because we are doing a hypothesis test and we're assuming that the difference in the proportions is 0, we can't use that to check the conditions. So we're going to use p hat here, p hat 1 and p hat 2, but we're going to use those 2 proportions to calculate the combined proportion, and the combined proportion is what you're using when you check the conditions. So p hat 1 is 0.92, and we got that by doing 460 out of 500, which is the information we got for the University of Michigan. We have a sample of 500 students or graduates from Michigan selected. P hat 2 is 352 out of 400, which gives us a value of 0.88. sample there again is 400. And now for the combined proportion, we take 812, which is the total number of graduates that got jobs, 500 plus 460 plus 352 gives us 812. We had a total sample size of 900, 500 and 400 from the two schools. And when we divide that, we get 0.902, which is our combined proportion. So when we check our conditions, we're going to use the two individual sample sizes, but the combined proportion. So N1 times combined proportion, N1 times 1 minus that combined proportion, N2 times the combined proportion. Oh, notice I have an extra 0 point in there that I don't need. And then N2 times 1 minus the combined proportion. Those are all greater than or equal to 10. So that tells us that our sampling distributions are going to be approximately normal. For the independent condition, we are sampling, and so we need to check the 10% condition. And so we have to check it separately for each school. So that means that 500 would have to be less than 10% of all U of M grads, which I think is pretty safe to assume. And 400 must be less than 10% of all MSU grads, also probably safe to assume. Now we are going to name our test. That's the next step. This is going to be a 2-sample z-test for P1 minus P2. And so then we're going to calculate our test statistic. So again, I'm going to fill these values in for you just so you don't have to copy them from the previous page. P hat 1 was 0.92, N1 is 500, P2, P hat 2 is 0.88, N2 is 400. Our combined proportion we calculated to be 0.902. So here is our test statistic. And this is the formula again, and you don't need to recopy the formula. I just wanted to show it to you so you don't have to flip back and forth. In the numerator, we subtract our two proportions, so 0.92 minus 0.88. And then in the denominator, we're using the combined proportion of 0.902 along with our two separate sample sizes. So there's what the calculation looks like. Just like we've done with one sample test, I would recommend that you do the denominator first, then take the difference on top, which is 0.04, and divide it by whatever you got from the denominator. And because we're working with a z-test statistic, we'll round that to 2 places, and that gave me z is 2.01. Now, the process for obtaining the p-value is exactly the same for 2 tests as it is for 1. And because we're doing a z-test, you'll use your green table A. We want the area in the curve that is to the right of 2.01. So what I did to obtain the p-values, I actually looked up negative 2.01. Then the table gave me the area to the left, which will match the area for the right, and that gave me 0.0222. Now we need to do the last step, which is to make our decision or give a conclusion. So because the p-value 0.0222 is less than 0.05, we will reject the null hypothesis. That tells us that there is good evidence that a higher proportion of recent graduates from Michigan get jobs than recent graduates from Michigan State. All right, we have done one example of a confidence interval and one example of a test, and you should have the packets for Chapter 10 for the assignments. Your assignment for tonight is to do the 10-1 worksheet. I will post the keys sometime soon if they're not there already. Again, please email me if you have any questions or having any trouble with anything, and I hope you guys have a great weekend.